Hello and welcome everyone to today's live session for the subject Strategies for Sustainable Design. As very few members have joined us till now, let's wait for 5 more minutes and see if other people join, and then we can start today's session. It is 5 minutes now, so I think we should start. I hope I'm audible. Sagar, can you let me know if I'm audible? You can just type in the chat box. Sagar, are you present? Okay, no issues. I think I'm audible as I can see this icon here. Okay, I'm audible. And can you see my screen? Yes, okay, great. Let's then proceed with today's live session. So welcome all to today's live session. Today is the live session for assignment 2 for week 2 of this course. So the course instructor for this subject is Professor Shivaji from IIT Hyderabad, and I am the teaching assistant. I am from IIT Roorkee, and I will be taking the live sessions for this subject. I'll be helping you out solving questions from previous runs of this assignment so that you can have a look at how the assignments are to be solved, how you can approach them. I'll even tell you the background material related to all the assignments, and then I'll show you how to proceed with solving the questions. The questions which we will be solving are from previous runs of this subject or this course, so it won't be the same as the ones you are assigned in this run. So your assignments, the questions in your assignments will be a little different from the ones we'll be solving here, but we hope that attending these sessions will help you understand how the questions are to be solved and how you can approach them. And also it will if you have any doubts about any of the questions, you can ask here in this live session, and it will help you further for your exams as well. So a little bit about the lectures which were covered in this week. So this is the list of the lectures which you would have gone through in week 2. So first is environmental sustainability. So environmental, social and economic sustainability, these are the three different aspects of sustainability as we learned in week 1. So this week detailed account of what each kind of sustainability means, what kind of aspects are covered under each, what kind of policy decision making and everything each of the types of sustainability influence, all such things would have been covered in these lectures. Then you would have studied climate change mitigation and the way forward. So as we all know, climate change is a very pressing issue in the current global stage, and it is highly linked to the issue of sustainability because as we all know, climate change threatens the way our society and our ecosystem is is, uh, is sustained. So it challenges if we can the process of climate change. It challenges if the way the thing our consumption patterns, our development patterns, and the way the ecosystem and socio-ecological systems function. It challenges the way it has been going up until now, and so in this chapter you see how we can mitigate some of the changes. We'll see how you would have seen how some of the changes can be mitigated and what is the way forward. Knowing that climate change is a process that is occurring and it is going to occur in the coming decades. And the last lecture you would have had is the future of human habitation and design. So this would have you would have gone in a little bit of detail about how human habitats are designed, and with the way things are, and with the all of the sustainability concerns surrounding environmental, social and economic sustainability, how human habitats can be designed in the future so that we do not follow a path which is not sustainable. Okay, let's now move on to the question and answers. So, as similar to previous classes, I'll solve the questions from previous assignments. If you have any doubts in between, you can just type in the chat box, and I'll get to your doubts after the end of the question answers. Or you can even pose your doubts after the questions and answers are finished. So let's start with the questions. So, first question for today is, which of the following does not represent environmental sustainability? And then you are given 4 choices. First is protect health of ecosystem, then targeting welfare, not just GDP. GDP is gross domestic product. And avoiding excess pollution, and then intergenerational decisions. And then you are given options if about choosing some of A, B, C, D, or all of it or none of it. So one thing you need to keep in mind while solving these type of questions, how the question is phrased. So pay attention that it says which of the following does not represent. So don't confuse it if in a way that it's asking which of the following represent. Pay attention on what the question is actually asking. So it relates to the concept of environmental sustainability, what environmental sustainability exactly means. So what environmental sustainability exactly means is that you treat all the environmental resources in a way that they have their own intrinsic value, that they have their own right to exist, and they do not exist just to provide some monetary value to humans. So many a times the value of environmental resources, they are by especially if you go from a view of an economist, the value of any environmental resource is just by what we gain financially from that economic resource. So if humans can gain something from the economic resource, if by processing it, removing it, or using it up, we can gain some financial value from that resource, we use that resource in a way, or we try to use that resource in a way so that we can maximize the benefit we get out of it. And by benefit I mean economic benefit, if you see it from the perspective of purely economical sense. So environmental sustainability does not follow that line of thought, following just the cost benefit analysis of whether we gain from any environmental resource or not. Treating what the line of thought following environmental sustainability means is that we should protect a resource because it has its own intrinsic value. It is although it can provide us some financial gain, but the value of that resource itself is larger than that short term or long term gain which we can have from that resource. So there are several aspects which are linked to environmental sustainability, and the question, as you know, pertains to that only. So you would have studied this diagram in the lecture, and it tells you about the key aspects which are linked to environmental sustainability. So first is intergenerational decisions. So what it means is that as as environmental and economic sustainability are not totally different, there are several linkages between the both. So we do have to make a lot of economic decisions for our environmental resources as well. So what intergenerational decisions basically means is that we make choices, or we make decisions for economic for getting economic output out of environmental resources, but we make those decisions keeping in mind that we are not the only generation who is going to use that resource. The generation after us is also going to be using that resource, so we use the resource in such a way that that use can be sustained over time. So it can be sustained in a way so that the generations which come after us can also use it. So we shouldn't use it in a way that we empty out all the resources and the generation who comes after us has nothing to use. That is what is meant by intergenerational decisions. Another component of it is looking at target welfare or targeting the welfare of the community and not just looking at the GDP. So GDP is gross domestic product. So gross domestic product is a economical term which is used to signify what is the total output or economic output of a country. So that what it means. So but what environmental sustainability tells is that you cannot judge how sustainable or environmentally sustainable a country is just by looking at their GDP, because GDP is just an economic measure of how the country has used its environmental resources and what value it has gotten out of use of those resources. Uh, for a country to be environmentally sustainable, you also need to see what welfare the use of those resources has provided to the community and as well as to the uh, other living beings or other components of the ecosystem which form a part of that country. So many a times there is this criticism, even there is criticism by many academics, that whenever we view environmental sustainability or whenever there is talk of environmental resources, it's largely a very anthropocentric view. So we view all these environmental resources keeping humans in the center, and everything, all the resource use, all the costs and benefits which arise out of the resource use, they are centered around humans. What they argue is that other components of the ecosystem, uh, other other living beings which are part of the ecosystem, they have even they have as much a right to the use of the environmental resources as human beings. So while we talk of GDP, that is what economic output humans are able to get from those resources, we should also see to the welfare of what all members of the community and all members of the ecosystem get from the use of the environmental resources. So that is what is meant by targeting the welfare and not just the GDP. Moving on to the next component, which is avoiding excess pollution. So this is a very key example of environmental sustainability, because many a times our use of the environmental resources generates certain byproducts or because of our activities, several byproducts are generated which then go into the environment, which pollutes it. So in order to maintain environmental sustainability, we have to make sure that the activities which we perform using the environmental resources, when we should base our activities in a way so that the end products we are generating, it's not just helping us, but the end products we are generating as a part of that consumption process, it's not harmful to the environment in which we live. That is another key aspect of environmental sustainability. Then coming to protection of health of ecosystems. So this is again avoiding excess pollution is one component of protection of health of ecosystem. Then several other things can be part of protecting the health of ecosystem. Ecosystem health can be impacted by many small and big changes which we make. So the way we use the environmental resources, what output we produce, at what rate we are using, are we using it in such a fast rate that it's not able to regenerate. All those things affect the health of ecosystem. And then what kind of resource are we using? Are we using just one resource, so that that resource is getting depleted, and other components of the ecosystem, so other living beings or other elements of the ecosystem who also depend on the same resource, are they not able to use that resource because we have taken so much of it, and then the ecosystem is getting poorly affected. All such things affect the health of any ecosystem. So we have to take care that we use the natural resources in a way that it's not irreparably damaged. Of course, any human activity which perform, it takes some resource from the ecosystem, but we have to make sure that our activities are such that even after taking some natural resource, the ecosystem is able to regenerate the resource and then regulate all other components of the ecosystem. Then is the shift to renewable resources. So as you know, this is again a very important aspect of environmental sustainability. A lot of the resources which we use are non-renewable resources. A very good example of this is fossil fuel. So fossil fuel is actually not non-renewable if you see the broader sense, because fossil fuels are generated through natural processes, and over a large period of time they will be regenerated. But then the key factor here is over a very large period of time. So the fossil fuel which we are using, it took thousands of years for that fossil fuel to be generated, to be created by nature. But at the rate we are using it, nature cannot regenerate the fossil fuel in such short amount of time as fast as we are using the fossil fuel. So that is why we should try to shift to renewable resources. So fossil fuel produces energy. So an example of shifting to renewable resources for energy would be to shifting to solar power, or to shifting to wind power, or hydroelectricity, or such things. So all of these things, they are generated in nature more frequently, they're regenerated more frequently as compared to fossil fuels. So in that sense, they are renewable resources, so they are made available to us quite frequently uh, through the cycle of nature, as compared to things like fossil fuel, which takes very large amount of time to be regenerated. So if we shift our resource use from something that is regenerated quite frequently from something that is regenerated in a very long time to something which is regenerated quite frequently, we have more control over how if us and our next generations can use it, because the resource is not getting emptied, or it's not getting finished very quickly by us. So in that way, shifting to renewable resources makes sense for environmental sustainability. I hope that is clear. Then long-term health of ecosystem, intergenerational decision making, and renewable resources, you understand. There are more other concerns. There are several other concerns also which are related to environmental sustainability. Uh, they can be things like preventing the consequences of man-made global warming. So man-made global warming is a result of the release of greenhouse gases into our environment. And as we saw here, avoiding excess pollution is one aspect, but even the release of greenhouse gases in the environment, it is a product of our use of fossil fuels and other activities. So in the end, we are releasing an end product into the environment which is affecting the environment poorly. So that again is not an example of pollution, but it is an example of how we are putting out waste or end products into the environment, which is having complex effects on our in, on our atmosphere, and then creating global warming. Then there can be things like protecting species diversity and ecological structure. So this can be a part of long-term health of ecosystem. So as we all know, different species of the ecosystem and of the ecological structure have their own functions assigned in the ecosystem, and they are balanced with each other by very complex and uh, intricate structures. And even if some component of the species diversity or of the ecosystem is affected in some way, the whole ecosystem, the balance of whole ecosystem can be disturbed. So protection of species and species diversity and ecological structure is also one component of environmental sustainability, and it can be linked to the long-term health of the ecosystem. And then targeting social welfare or happiness, as I mentioned. So these are the components of environmental sustainability, as we saw. So I hope it is clear to you now how this question can be solved. Another thing which is very important, uh, I'm so sorry, just give me one moment. Okay. Another thing which is important when talking of environmental sustainability are how environmental sustainability can be promoted. So although this is not a part of the question, but when we talk of creating like shift to renewable resources, protecting the health of ecosystem, avoiding population, and making decisions for environmental sustainability, several things come into play. So one key way in which we ensure that we promote environmental sustainability is through policy. So these are some examples of how policies can promote environmental sustainability. So first is carbon tax. So carbon tax is example of a tax which is introduced to discourage the use of fossil fuels, or discourage the use of release of carbon dioxide into the environment. So a tax is placed on production and consumption of carbon. So for example, if you burn fossil fuels, you are generating a lot of carbon dioxide which is released into the environment. So the why we introduce such taxes is to make the users face the full social cost of performing that activity, as opposed to just the private cost that is incurred by them in doing that activity. So what this means is that private cost is defined as a cost which any individual faces uh, by when uh, which private cost is the cost when which any individual faces directly in a transaction, whereas social cost is something uh, which the individual faces as direct part of the transaction, but it also involves the cost which the consumers of that product will face due to the exposure uh, to the transaction which they are not paying. So for example, when you're burning fossil fuel to make something, you are directly incurring the cost which is used for uh, that fuel and things. But then there is a cost to the environment also, or cost to the community which has to face uh, the impact of global global warming or pollution that is generated by burning that fossil fuel. So in that sense, such taxes are introduced so that the user pays for the full social cost as opposed to just the private cost of using that fossil fuel. Then there are government regulation to limit harmful emissions. For example, many cities are promising to ban diesel cars by certain dates. And then another very good example of this is that the reduce or stopping of use of chlorofluorocarbons or of the activities which emit chlorofluorocarbons. So as you might remember that decade ago there was a huge problem of the ozone layer thinning in of our atmosphere, and during that time it was recognized that chlorofluorocarbons play a huge part in the ozone thinning, and then there was a decision made, and globally many of the countries all over our globe decided to reduce and limit the use of chlorofluorocarbons or limit the release of chlorofluorocarbons in the atmosphere. And owing to those regulations, now the ozone layer of our atmosphere has healed. So that is one very good example of how government regulation can limit harmful emissions. Then there are things like subsidies or encouraging more sustainable environmental practices. For example, subsidies or tax benefits can be provided if an individual or a community is trying to move towards a renewable energy like solar and wind power, compared to if they are relying on non-renewable sources. So I'll give you an example. In many of the cities in Western countries, there are now a lot of subsidies and tax benefit if you use renewable energy like solar power or wind power for heating and such purposes. So that is one example. Then another example of a policy would be include making a decision related to use of any natural resource based on thinking of all the environmental consequences which go with that decision making, not just focusing on the current short term consequences, but thinking about all the environmental consequences and then making the decision. And then last is trying to shift the consumer behavior through persuasion and use of behavioral economics. So an example for this would be, you might know that Norway has a lot of oil reserves, but because Norway is trying to reduce its oil, the usage of oil or the people's dependence on oil for transportation purposes. So the government of Norway, it provides a lot of subsidies on electric vehicles so that people try to shift their dependence on from their dependence on oil for their vehicles to EV. Another example I can give you is that in Germany there is a system called a fund. So what this system entails is that whenever you buy a product which has plastic packaging, so it mostly for beverages and other such things which come in plastic bottles or other such kind of plastic packaging, you are charged a small fees for that plastic packaging. So what you can do is that you can get the fee back when you submit your plastic empties for recycling. So it encourages the behavior of recycling and trying to use less plastic. So this is another example of shifting consumer behavior. I hope this is clear and that you understood all the background material which is required to solve this question. Moving on to the next question, which is the Chernobyl disaster in Russia. It's a famous for which type of disaster? And you have options: flood, biowarfare, nuclear, or earthquake. So this is a very famous example of a nuclear disaster or nuclear accident, and I think you would have studied this in your lectures also. So Chernobyl disaster or the nuclear accident at Chernobyl. Chernobyl is a place in Russia. It occurred in 1986. It occurred in 1986 in at the Chernobyl nuclear power station in Soviet Union. And it was the worst disaster of history of nuclear power generation. So what happened was there and a nuclear accident occurred at the Chernobyl power station, which was situated at the settlement of Pripyat, which is 10 miles from the city of Chernobyl. And what happened was, after the disaster, the Soviet Union had to create an exclusion zone of a radius of 18.6 miles around the nuclear power plant, and this was further increased in later times. So, although the nuclear power station was creating a lot of electricity for the area, and if you see, so nuclear energy generation is quite a non-polluting way of generating electricity or generating energy for usage. But what this disaster uh, taught us was that we have to think about all of the consequences which any human activity can have it, and the consequences should not only focus on the short term but even on the long term effects of any resource use or any activity that humans perform. So, because there were not good enough security measures in place, such disaster occurred, and as an impact of the disaster, a large part of land and all the natural resources which were a part of that land are now unusable. They are rendered unusable. The area is rendered uninhabitable, not only for humans, but there are cases of severe adverse effects on the plants and animals of that area as well. So that is why it is very crucial to consider the environmental sustainability comprising of all aspects, and for both for long term and short term periods. Moving on to the next question, which is New York City reported annual energy savings of about 81% across the period of 10 years by replacing all of its street light with what? So you are given 4 options: CFLs, incandescent bulbs, LEDs, and motion censored fluorescent bulbs. So, as this question talks specifically about New York City, so it talks specifically about one example or one case study in a sense. So, for the specific case of New York City, the answer is LEDs. What the city did was it replaced their street lights with LEDs, and ultimately they saved about 81% of energy over a period of 10 years. But important thing here for you to learn is that you learn the differences between the efficiency of different types of lighting fixtures. And by efficiency I mean what output of light they provide using what amount of electricity. So as you can see from this image, that it compares candle light, incandescent bulbs, CFL and LED. So you can see the efficiency of candle light is the lowest, and then it increases with the incandescent light, then with the CFL, and then with the LED. Also, lifespan of candle light is the lowest, of an incandescent bulb is slightly more, which increases with the CFL, and then the lifespan of an LED is greater, or the greatest. Uh, in this sense, not only the LED is best in terms of efficiency, but is also best in terms of the longest lifespan. The only problem with the LED, which is encountered by people a lot of time, is that the upfront cost of installing an LED is greater than that of an incandescent bulb or a CFL. But what cost the LED, what extra cost the LED entails in the beginning, that cost is recovered over time because of the efficiency with which the LED provides uh, you the light. So the amount so the extra amount which is incurred in the initial cost, it is recovered over time by the reduced amount that you have to pay for the electricity use. So in that way, things like reduced energy cost, or uh, reduced energy usage, such things can be calculated uh, based on these metrics. Another way which you can see and use the metrics is through such charts. So this chart I have gotten from a company which manufactures LEDs. The company's name is Very Bright. So they have created a chart for their specific products. So similarly, you can get charts for different products from different companies, and in those they provide you with a list of what uh, they provide you with the details of how much wattage is needed for producing how much brightness. So based on your need of how much brightness you want in a room, you can calculate how much wattage of electricity will be required, and how it is different from incandescent yeah, how it is different from if you use an incandescent lamp. And then based on how much electricity you'll need, you can calculate the cost of electricity, and then add calculating the upfront cost of LEDs, and then upfront cost of an incandescent bulbs, and then comparing how much it will cost you to use different options over a period of time. You can see which of them are more economical, which of them use less electricity, and all such things. So I have provided this link in the presentation, which will be made available to you. So later at your own time, if you like, you can go to this link and visit that website, and there you can read further about different aspects. So there are things like color rendering of different options as well. Then this I showed you what level of brightness and what level of wattage is associated with different lighting fixtures. And then you can even see their calculation of which are more cost effective. So it then again it has similar calculations like average cost of one bulb, and then what is its average lifespan, and then how many bulbs you'll need for that many hours. So based on each bulb's lifespan, they have calculated how many bulbs you'll need. So they have done an estimation of over 20 years how much each type of bulb will cost you. Similarly, using this information, you can make calculations for yourself as well. So if you want to see more, you can visit this website and see further. Coming back to our presentation, so I've also mentioned what lumen means. So lumen is actually the unit of luminous flux, or the amount of light which is present in any given space. It can be defined as the amount of light streaming outward through one steradian. So steradian is one unit of solid angle from a uniform point having an intensity of one candela. So one candela is actually unit of luminous intensity. So lumen is unit of luminous flux, whereas candela is unit of luminous intensity. So candela can be defined as the luminous intensity in a given direction of a source emitting monochromatic radiation of 540 into 1012 hertz, and has a radiant intensity in same direction of 1 on 683 watts per steradian. So these are all technical terms. If you want to learn further about lighting and brightness and intensity and luminous intensity, how everything is measured, you can go to this link and you can see further. So for example, this is a lumen, sorry, and then candela, and then if you want to learn more about luminous intensity, all of such things you can learn further. Coming back, okay, so I hope this question is clear to you, although it mentioned the specific example of New York City, and for that the answer is LEDs. I tried to tell you a little bit about how the luminous intensity and the wattage of each of different types of lighting fixtures can influence your decision of which lighting fixture to use, and how you can make calculation based on what kind of brightness you want, over what period you want to calculate, and what wattage each of the different bulbs use. I hope this is clear. We'll move on to our next question now. So next question is what percentage of energy is lost in each step up the food chain? So you are given options: 10%, 80%, 90%, and less than 10%. So it talks about energy in the food chain, or energy in the ecosystem. So we all know that all living things need energy to do basic functions like to grow, breathe, reproduce, move, and several other things. But we also know that energy cannot be created from nothing. So it must be transferred through the ecosystem, so from one thing to another. So because all of the living beings need energy to perform their basic functions. The energy has to come from somewhere. So can anyone tell me where energy comes from? So all of course we know that because we eat food, we get our energy from food. But our food also is a part of ecosystem, because either we get our food from uh, plants or from animals, so either plant product or animal product. But even plants and animals are part of the ecosystem. So can anyone tell what is the basic most basic primary source of energy on earth? You can just type in the chat box and tell me if you know. Can anyone guess what the primary source of energy is? Yes, Vanita, please type your answer in the chat box. Akansha is saying ATP. I did not understand what ATP means. Light and heat. Okay. Light and heat are type of energy, or it's a type of energy, but what is the source of light and heat? Where is it coming from? Any other answers? Yes, Vanita, you are raising your hand. You can just type your answer in the chat box, or if you have anything else to ask, please type in the chat box. There is a option for in-call messages. It will be an icon next to the participant icon. So there is a icon which shows you all the participants. Next to that icon, there is a message box. You can. Okay, Vanita is saying sun. Yes, that is very correct. So the primary source of uh, all energy on earth is the sun. So how we get that energy is through transfer from the ecosystem. So plants are the basic or the primary producers, which convert that energy from the sun, solar energy, into the energy which is usable in the further trophic levels. So they convert that energy and store it, produce their own food from that energy, which is in the form of glucose, and then this is also stored in those plants or the primary producers, which is then further used by uh, uh, organisms in different trophic levels. So primary producers, they are eaten by primary consumers, so uh, organisms like small organisms which are herbivores, for example earthworms or rodents and things. And then they are eaten by secondary consumers, so which belong to the third trophic level. So smaller carnivores, then they are eaten by further animals in fourth trophic level. So in this way energy is transmitted, or uh, it goes from one trophic level to another trophic level. So all the energy which is generated by the primary producer is called, or all the biomass that is generated by the primary producer is called gross primary productivity. But even the primary producer needs some energy for respiration. So then reducing that energy needed for respiration from the gross primary productivity, it gives you the net primary productivity. So it is the productivity that is left over after the primary producer has used the energy. So not although energy is transferred from one tropic level to another, not all of the energy which is there in one tropic level is transferred to the next higher tropic level. At each of the tropic level, some biomass is consumed and excreted as waste, so it is not transferred to the next tropic level. And a lot of the energy which is transferred from one to the next is also converted into heat, and then because of that it is unavailable for the next tropic level. So heat, it's converted into heat during the process of respiration. So on an average, only about 10% of the energy which is stored in the form of biomass in any given tropic level is transferred to the next tropic level. So this is known as the 10% rules, uh, which uh, which says that of all the biomass, uh, of all the energy which is stored in the form of biomass in one tropic level, only 10% of that energy is transferred on to the next tropic level. So uh, what this does is this also limits the number of tropic levels that an ecosystem can support. So the more biomass is stored in the primary tropic level in any ecosystem, the more number of tropic levels that ecosystem will have. So for example, you see the desert ecosystem, even the primary tropic level in a desert system ecosystem does not have that much biomass, uh, that much energy stored in the form of biomass. So the number of tropic levels of a desert ecosystem are very less compared to uh, the number of tropics in another kind of ecosystem. I hope this is clear. So what the question is asking, what percentage of energy is lost in each step of the food chain? So we know that only 10% is, on an average, only 10% is getting transferred. So if 10% is getting transferred, that means the remaining is lost. So 90% of the energy is lost uh, uh, when each step up from one tropic level to another tropic level is happening. So I hope it is clear. We'll move on to the next question. So the next question is the capacity to come back to the normal position without much of external intervention after having gone through some catastrophic event or same kind of damage in environmental sustainability is called what? Then you are given four options: resilience, vulnerability, fragility, and fatalism. So all these terms are related to risk and risk management, and I'll explain all of the terms to you so you can get a better idea of what all the terms are, and you can move ahead with this question. So vulnerability and resilience, they are actually both related terms, and they are related to each other through the concept of risk and risk management. So what risk is that here it is mentioned in terms of economy, because it is taken from a study which studies the risks, vulnerability, and resilience of an economic system. But it can be the concept is very similar and can be studied for different kinds of systems. So it can be for an ecosystem, an urban system, economic system, socio-economic systems, and different things. So what risk is? Risk is the chance of any economy or any other system of being harmed by an external shock, or it can be shock or even some kind of stress. So shock are a sudden event of disturbance, and then stress are event, not sudden events but gradual slow moving disturbances, or negative impacts on any kind of system. So what risk is defined by the vulnerability of that system and the resilience of that system. So what vulnerability is? Vulnerability is the function of exposure and the inherent features of that system. So exposure means to what kind of uh, risks or external shocks or hazards the system is exposed to. Is it in a place where it is exposed to a lot of stresses and stress and possible shocks or hazards that can occur to it, or is it in a place where not many risks or hazards occur? And then inherent features. So inherent features are the uh, qualities of that system which are ingrained within the system, which can help it to be less or more vulnerable. So for example, they have given taken the example of economy here. So if the economy has trade openness, does it have export concentration, is it dependent on strategic imports of such things? So these are the kind of inherent features which make an economic system less or more vulnerable. Then comes resilience. So resilience is defined by two things. First is uh, the coping. Uh, so policy measures is an example. So resilience is defined by the coping ability of that system. So the how the system is able to cope with any external disturbance or any shocks or stresses the system faces. Is it able to bounce back from it? Is it able to bounce back to the same level, or is it able to adapt so that it is prepared for such disturbance in future? Is it better prepared? And such things are part of resilience. So I'm so sorry. Resilience and vulnerability, they are related, but they're also explained by different academics and different schools of thought in different ways. So one school of thought treats risk as a function of hazard, uh, exposure, and vulnerability. So this is called the risk triangle or Crichton's triangle, in which risk is considered as the area of this triangle, and which is a function of hazard, vulnerability, and exposure. So each side of the triangle is one of the things. So one side is hazard, one is vulnerability, and one is exposure. So if even one of the three things is zero, so if even one side of the triangle becomes zero, the area of the triangle will be zero. So this is how this concept explains risk, vulnerability, and things. So if hazard, exposure, or vulnerability becomes zero, then the risk on that system becomes zero. So this is one way of understanding vulnerability. Then there are ecosystem response frameworks also. So here you can see this is how the ecosystem is functioning when it's not being disturbed by any external shock or stress. So it is not a constant thing, because ecosystems are dynamic themselves. So even there are some disturbances in the ecosystem, even while some not disturbances but some irregularities, even while there are no disturbances. So here is where the vulnerability analysis of the ecosystem can be done. So when the disturbance occurs, so from a high variable state, the ecosystem goes to a low variable state. Low state variable. So from a high functioning or high uh, state, it goes to a low state when a disturbance occurs. So it has several choices after the disturbance occurs. it can remain at that low state. This will happen if the system does not recover, or another thing it can do is that it can recover and go back to its normal state. So this is the quality of a resilient ecosystem, that even after the disturbance occurs, it goes back to its normal state of functioning. And then the adaptive state of functioning is that it recovers and goes back to a state which is even higher compared to its earlier uh, state that was there before the disturbance. So the amount which it dropped due to the disturbance, it shows the magnitude of the disturbance or the sensitivity of the system to that specific hazard. And then this is the reaction period, so the time it takes for the system to go from the low state variable to back to its earlier state, that is the reaction period. I hope this is clear. Then, as I mentioned, that the disturbance can be a sudden shock as well as a gradual stress. So, this is example of how development activities can be affected by some sort of stresses or shocks. So, for example, if we talk about urban development, there can be gradual stresses, like for example, uh, uh, several aspects of climate change, like rising temperatures or reducing water quality or reducing water availability. They are gradual stress which affect the development of a city. So if this is the development trajectory of the city, the trajectory will be affected slowly over time due to that stress. Or then there can be an example of shock. So extreme climatic events, for example, some kind of flood or cyclone, so they occur in a very short period of time, and they affect the system by shocking it. So this is example of that. So ultimately output is that it is the trajectory of development is brought down from its earlier higher level to a lower level, so, in both cases. And then what resilience would be is going back, not only going back to the earlier level of development, but even keep moving further from initial development. So if the trajectory was like this, then reaching at a point that the trajectory continues. So I hope this is clear. I have also provided the links of each of the papers. So for example, this is the paper telling you about risk management approach of resilience, and how effect of shock and stresses on development pathways occur on different levels of resilience. You can go through this paper if you want. I have provided the link in the presentation, and the presentation will be available to you after this. So even for ecosystem response framework, there is a link to that paper. And for understanding vulnerability and resilience as uh, for an economic system, the paper's link is also here. So I hope vulnerability and resilience are clear to you. and it is clear to you that the capacity of a system to come back from to the normal position after having gone some through catastrophic event, it refers to resilience of that system. Another term which is talked about here is fragility and then fatalism. So fatalism is nothing but it's also part of risk management. So fatalism is the inherent capacity of any event or any disturbance which occurs to cause fatality to human life. So that is what is meant by fatalism. What fragility means? So fragility can be for several things, but usually it's studied in terms of ecosystem. So ecosystem fragility, ecosystem fragility is that it is inherent property of any ecosystem which has certain fragility, whether or not it is exposed to any disturbances. So it is to quantify how fragile the ecosystem is, or how sensitive the ecosystem is to any disturbance if the disturbance is to occur. So the problem with the concept of fragility is that it is only measurable once the disturbance occurs. So it can either be a natural disturbance or a human caused disturbance, but after the disturbance occur, uh, how much the ecosystem has reacted to that disturbance can help us measuring how fragile the ecosystem is. So relating ecosystem to their disturbances can help provide useful assessment and approach closely related to the environmental impacts. So seeing how one disturbance affected one ecosystem at one point can help us assess if a similar disturbance occurs on a similar ecosystem, how it will affect that ecosystem at some other point of time or at the same point of time, such things. So that is what fragility means. So I hope this question is clear to you all. Moving on to the next question, which is, as per the UNFCCC report, which country has the highest cumulative CO2 emissions from fossil fuels and cement from year 1751 to 2017 in billion metric tons of CO2. So I think this you would have studied in your lectures. So it is this UNFCCC report where you would see uh, this figure depicting the cumulative CO2 emission of different countries. So what the question is asking is which country has the highest cumulative. So you can see here USA is the country which is the highest cumulative CO2 emissions. But apart from that, if you want to learn more about the GHG emission of different countries, you can even go to UNFCCC's website and see their inventory of GHG emissions from different countries there. So why this is available? Because in accordance to the Article 4 and 12 of Climate Change Convention, it was decided that in the conference of parties, the different parties of different countries which were party to that uh, conference, they will submit their greenhouse gas inventories to the climate change secretariat. So this was done in order to maintain transparency of how much greenhouse gases are being released into the environment by different countries. So I have provided the links to the GHG emission inventory. So there is a link for the time series data of greenhouse gas emission, and then for there is another link which you can go to see how emission from different countries, and then you can compare the emission of from different sources within the same country or among different countries and such things. So I'll show you a little bit. So this is the time series data of greenhouse gas emission. You can see, so for example, greenhouse gas emission for Austria. So for the base year, then in 1990, 1995, how throughout the years the emissions have changed. The data is up till 2020, and then they have also calculated for you change from the base year to the last reported year. So if there is a positive percentage, so it means a percentage increase in their emission measured from the base year. If there are negative percentages, so it means that the emissions have decreased compared to that their base year. So for example, you can see countries like Cyprus, they have increased almost 60% from their base year. Then there are examples like uh, this. So this is Lithuania. Lithuania is negative 57.83%. So it means that they have reduced their emissions almost 60% of their base year. So this you can see. You can even export this data to Excel if you want to do your own calculations or own assessments of things. You can export it to Excel and then do your own calculations if you want. Coming back, this is the GHG data for different countries, and so there are several things. So you can even see the global map. And the data plotted on the global map of for different countries. And you can again download this if you want from this print link. Then you can even see detailed data by party, and then you can select, and then you can select if you want the base year or for all years and things. So for each country you can do. Another thing you can do here is you can compare by which type of gas, then compared by which category. So for example, you select one country and another, and then you see aggregate GHGs, or you can select if you only want to see for CO2 and such things. Such data also you can get from here. You can export to Excel if you want to get this data and do any sort of calculations or assessments for yourself. I hope this is clear. Okay, coming back. So this question I think is clear to you. We'll move to the next question. So next question is in the environmental pyramid, which food has the highest environmental impact as per the Barilla Center for Food and Nutrition of 2012? And then you are given four options: oil, cheese, red meat, and poultry. So this is the food pyramid which it is talking about. So as it relates a little bit to the food chain pyramid as well, but several other things. So for example, it shows you from high to low, or from high to low, what suggested intake, what intake of food is suggested more for your uh, food consumption to be environmentally sustainable, and then uh, from low to high, how much environmental impact different kinds of food make. So for example, you see the impact, the food, like food coming from the lowest tropic level, like fruits and vegetables, they create the lowest environmental impact. And as you move higher up in that tropic level, so like food coming from uh, animal sources, the impact generated by them is more, and the amount of intake suggested by this food pyramid, so this suggested by the Barilla Center of Food and Nutrition, is also is reducing. So why this occurs is because uh, the amount of energy which we can get from food which is belonging to a lower tropic level is should be more than the amount of energy we are getting uh, uh, from a food which is belonging to a amount of energy we are getting from a food which comes from a tropic level which is higher up in the ecosystem. So this is because the amount of energy which is uh, consumed in creating that food is more as compared to amount of energy which is consumed in creating a food which belongs to a lower trophic level. Apart from that, there are several other things such as production, the energy which is required in production of several foods. For example, cheese, fish, cheese, biscuits, and sweets, so like things like sugar, all of these things are highly processed, and it takes a lot of energy in processing and making these foods. So then again, a lot of energy is required in processing this. So this is why again foods, highly processed foods, are also placed in higher up in the food pyramid. So uh, coming back to our question, so what the question is asking, which food has the highest environmental impact. So we'll go, we'll see this line here. So this is the area of highest environmental impact, and this is the lowest environmental impact. And our options are oil, cheese, red meat, and poultry. So you see red meat is at the highest level here. So that is the correct answer for this question. I hope this food pyramid is clear to you. We'll move on to the next question. So next question is, who said Earth provides enough to satisfy every man's needs, but not every man's greed? So this is a famous quote by Mahatma Gandhi, and he said these words in with respect to sustainability and environmental sustainability, and by this he means that Earth has enough resources to sustain our uh, needs, or whatever needs humans have, but it but because of our ways, our consumption patterns have changed owing to capitalism and constant human need to generate more and more economic output of from our natural resources. So that has been treated as becoming greedy by Mahatma Gandhi, and that is why he has uttered these words that Earth provides enough to satisfy everyone's needs, but not enough to satisfy man's greed. Coming to the next question, how many goals on sustainability has the United Nations provided? So this we covered in the last lecture as well. So United Nations has Sustainable Development Goals, the UN SDGs. So these are the 17 Sustainable Development Goals which are provided by the UN, and this is the link which I provided in the last lecture as well. So you can go to these links and you can check out all of the United Nations Sustainable Development Goals for yourself. The last question for today is that which goals in the United Nations Sustainable Development Goal talk about global warming and GHG specifically? And your options are climate action, sustainable cities and communities, and life on land, and then none of the above. So one way of thinking and answering this question is seeing at it rationally of which of these might talk about global warming and GHGs. So climate action is something which is highly linked to greenhouse gases and the greenhouse effect. So this shows you how greenhouse gases and their emission is linked to climate change. As you know, normally we have CO2 in our atmosphere, and we have the sun, and solar radiation from the sun travels to our environment and reaches the earth. And this presence of CO2 and some amount of greenhouse gas in our environment is essential also, because to keep the earth warm at night, when the solar radiation is not hitting the earth, it is essential to keep the earth's temperature warm enough for life to be sustained on earth. But because of human activities and the CO2 in the environment has increased rapidly, and because of that, what is happening that more and more solar radiation from the sun is being trapped in our atmosphere as more and more greenhouse gases are released. So because of this, less heat is escaping back into the atmosphere, and the Earth's atmosphere is getting heated, and because of that, global warming is occurring and our climate is changing. So if you think rationally also, climate action is largely related to global warming and GHGs. Apart from this, another way of seeing that which of the UN SDGs are directly related to global warming and climate and GHGs, you can go to the UN SDGs website, like I mentioned last time, and you see the specific uh, the specific goal which the question is asking. So let's see life on land. So this is the goal 15, life on land. You can click here to more info, and then you can see the different targets and indicators. So target 1, there are several targets and indicators, and you can check if any of these targets, do they talk about greenhouse gases or not. So for example, this target talks about conservation and restoration, sustainable use of terrestrial inland freshwater ecosystem and such. So it definitely does not talk about greenhouse gases. Whereas if you go back and you go to climate action indicator, you go to targets and indicators, you see the first target is to strengthen resilience and adaptive capacity due to climate related hazards. Then there is integrate climate change measures into national policies, strategies and planning. If you see its indicators, one of the indicators is the total greenhouse gas emission per year. So how much greenhouse gases are being emitted, that has to be incorporated into national policies and strategic planning. So from the target and indicators also, you can see that this SDG talks about greenhouse gases and greenhouse gas emissions. So that way also you can solve this question, that you go specifically to the targets and indicators of each sustainable development goal and see if it is related to greenhouse gas emission or not. I hope this question also is clear to you. That is all for today's question section. Thank you very much for attending today's session. I'll talk a little bit more about one question which was asked in the previous session. So someone asked about, just give me one moment. Okay, so coming back, someone asked about the vernacular architecture of Himalayas, if some sort of Himalayan vernacular architectural practices or some specific style of vernacular architecture exists for the Himalayas. I could not tell you in that, but I said that I'll find examples. So I do not know if the person who asked if they are present today, I think it was Arvind, or I might be wrong, but I came up with a few examples. So one example of uh, vernacular Himalayan vernacular architecture is Katkuni construction. Yes, okay, Arvind. So good that you are here. Uh, so one example is the Katkuni construction. So Katkuni construction technique comes from the region of Himachal Pradesh. It is a special technique which uses wood and uh, wood and stone construction, and the word comes from wood, kart, which is Sanskrit kast, which means wood, and then corner. So specifically the corner joints which are made using the wood and rubble masonry, as you can see here, which is very uh, key to this kind of construction. And it is also called by different names like Katkona or Koti Banal in Uttarakhand. So it varies a little bit in the region. So it follows a similar pattern of construction, but it varies a little bit in how it is executed and how it is named. If you want to read further about it, I have provided several links. So this is how Kotibanal architecture tackles the problem of earthquake. All of these regions, the Himalaya regions, they see a lot of seismic activity. So even this kind of construction takes care of earthquake safety as well. So you can go to these links and see for yourself. It provides a detailed information of these techniques, of their specific architectural components, and what kind of materials they use, how the aspect of seismic vulnerability is taken care of, what their foundations consist of, what kind of masons are used, uh, uh, their construction styles, the materials, everything. So you can go through these PDFs which I've shared, and you can see more. Then Katkuni for Himachal Pradesh. So this is more of a documentation of the architectural style as compared to the other document uh, which talks about how earthquake safety is associated to this construction. So this documents the architecture and architectural style of uh, Katkuni architecture. So you can go through this as well, and then it also talks about how the settlements occur. So not only just the buildings, but even the settlements of which these buildings are part of, how the settlements are created. Another is vernacular architecture of Ladakh. So I don't think that there is a specific uh, name associated to it, but this is the architectural practices of Ladakh. So because Ladakh is a cold desert. Its climate is very different from other Himalayan areas like the Uttarakhand or Himachal Pradesh. So it has very different specific needs compared to other Himalayan areas. So I thought that mentioning this would also be helpful for you to understand how vernacular architecture relates to the climate of particular area. So you can go through this also to help you understand how specifically uh, Ladakhi houses are created, what specific materials are used, and how the different climatic aspects of the house are taken care of. I think uh, this is enough. You can go to these links and read further if you want. Uh, that is all for today's session from my side. If anyone has any further questions, please go ahead. If anyone has any questions, please. Vanita, I see your hand is raised. Do you have any question? Please type it in the message box. Anyone else? If anyone else has any questions till that time, please go ahead. Please ask. Okay, no questions from Parvat. Okay, I think that there are no more questions for this session. Thank you all for attending today's session. If you still have doubts later on, you're very welcome to ask them on the forum. Either me or Professor Shivaji can attend to your queries. Thank you very much for attending today's session. Thank you, Arvind. Goodbye.